Imagine something so powerful that it can swallow stars, twist light, and even slow down time itself. Something so dense that if you got too close, you'd never come back. That's not a science fiction monster. That's a black hole. Black holes are one of the most mysterious and fascinating phenomena in the universe. They defy common sense, challenge physics, and might even hold the secrets to how the universe works. Today, we're going to break down everything you need to know: what black holes are, how they form, what happens if you fall into one, and even how they might die. So buckle up, because we're about to dive into the darkest, strangest places in the cosmos. First things first, what exactly is a black hole? Despite the name, it's not an actual hole or tunnel in space. It's a region where gravity is so strong that nothing, not even light, can escape its pull. Think of it like this. If you were to escape Earth's gravity, you'd have to travel at about 11 kilometers per second. That's the escape velocity. But near a black hole, the escape velocity exceeds the speed of light. And since nothing can go faster than light, nothing gets out. That's why it's black. It doesn't emit or reflect light. It's a completely dark spot in space. The outer boundary of a black hole, the point of no return, is called the event horizon. If you cross it, there's no way back. Inside that lies the singularity, a point where all the mass is squeezed into an infinitely small space. At that point, gravity becomes infinite, and the known laws of physics simply stop working. We don't actually know what happens inside a singularity. It's one of the biggest mysteries in science, a place where space and time break down completely. Most black holes are born from the death of massive stars. When a huge star, at least 3 times more massive than the Sun, runs out of fuel, it can no longer fight against gravity with the pressure from nuclear fusion. The core collapses and the star explodes outward in a massive supernova. The remaining core keeps collapsing, shrinking smaller and smaller until it becomes so dense that it turns into a black hole. That's how stellar mass black holes form. They're the most common type we know of. But then we have the real monsters, supermassive black holes, found at the centers of nearly every galaxy, including our own Milky Way. These beasts can weigh millions or even billions of times more than the Sun. How they formed is still one of astronomy's great puzzles. Some scientists think they grew from smaller black holes that merged and swallowed up stars over billions of years. Others believe they might have formed almost instantly in the early universe, from huge clouds of gas collapsing directly under gravity. And somewhere in between are intermediate black holes, which could be the missing link between the two extremes. To sum it up, there are 4 main kinds of black holes we talk about. 1. Stellar black holes, formed when massive stars die. 2. Intermediate black holes, a mysterious middle ground, possibly created by merging stellar ones. 3. Supermassive black holes, gigantic ones at galaxy centers, including Sagittarius A star in our Milky Way. 4. Primordial black holes, hypothetical tiny black holes that might have formed just after the Big Bang. If primordial black holes exist, they could help explain dark matter, the invisible stuff making up most of the universe's mass. We haven't found them yet, but telescopes are looking. All right, let's get to the fun and terrifying part. What happens if you get too close? As you approach a black hole, gravity becomes extreme. If your feet are closer to it than your head, gravity will pull much harder on your feet. This difference in force stretches you out, a process scientists dramatically call spaghettification. It's not pleasant. You'd be stretched thinner and thinner until you're ripped apart. But that's not even the strangest part. If a friend were watching you from far away, they'd see you slow down as you approach the event horizon. You'd appear to move slower and slower until you eventually seem frozen in place, fading into red light. To them, you never actually fall in. But from your point of view, you'd fall straight through and never notice the exact moment you cross the horizon. That's because of time dilation. Time itself slows down near intense gravity. In fact, this isn't just theory. We've confirmed that time runs slower near massive objects, like Earth. But near a black hole, that effect becomes extreme. Remember the movie Interstellar? The scene where every hour near the black hole equals 7 years on Earth? That's based on real physics. So near a black hole, space bends, time stretches, and reality itself starts to twist. For decades, black holes were just mathematical ideas. We knew they should exist, but we couldn't see them directly. After all, they're black. Then in 2019, everything changed. An international team of over 200 scientists used the Event Horizon Telescope, a network of radio observatories spread across the planet, to capture the first ever image of a black hole in the galaxy M87. That glowing orange ring? That's hot gas swirling around the event horizon at nearly the speed of light. The dark shadow in the middle is the black hole's silhouette. It was a groundbreaking moment, proof that these cosmic monsters really do exist exactly as Einstein's theory predicted over 100 years ago. Since then, scientists have even captured an image of the black hole at the center of our own galaxy, Sagittarius A star. You'd think black holes live forever, right? Well, not quite. In 1974, physicist Stephen Hawking discovered that black holes aren't completely black. Thanks to quantum effects, they actually emit tiny amounts of energy, now known as Hawking radiation. This means black holes slowly lose mass over time. The smaller they get, the faster they evaporate, until eventually, they disappear in a burst of energy. Don't worry, for a black hole the size of the sun, that would take about 10 to the power of 67 years. That's way longer than the universe has existed so far. So yes, black holes can die, but it's a very, very slow death. You might be wondering, okay, but why do scientists care so much about these cosmic death traps? Because black holes push physics to its limits. They sit at the crossroads between general relativity, Einstein's theory of gravity, and quantum mechanics, which describes the tiniest particles in the universe. Right now, those two theories don't fully agree, but black holes might be the key to uniting them into a single, universal theory of everything. They also play a crucial role in shaping galaxies, influencing how stars form, and even controlling how galaxies evolve over billions of years. Without black holes, the universe as we know it might look completely different. So there you have it, everything you need to know about black holes. They're not just cosmic destroyers, they're gateways to understanding the universe itself. They bend space, stretch time, and challenge what we think is possible. And the more we learn about them, the more we realize how little we truly know. If you enjoyed this video, hit that like button, subscribe for more space stories, and let me know in the comments. Would you dare to go near a black hole if you somehow could? Thanks for watching, and remember, the universe is full of mysteries waiting to be explored.